Continuing our unit of soil, rocks, and landforms. This is Investigation 2, Part 1, Erosion and Deposition. So we're going to review first. So the question that we're going to start with is, what is soil? Well, soil is a mixture of weathered rock and organic humus. And what is weathering? Weathering is the breaking of rocks into smaller pieces. And what are some examples of physical and chemical weathering? Well, physical weathering could be when water freezes in the cracks of rocks and expands and it breaks the rocks. Physical weathering could also be when animals dig around in the area and break some rocks. And then chemical weathering would be minerals reacting with acid rain. So how does weathering contribute to the formation of soils? This is an important question when it comes to determining where those four soils came from. Well, weathering reduces rock material to smaller pieces. So it might become sand, it could become silt, and it could become clay. Sometimes the small rock particles we see in soils are found near the parent rock. A parent rock is the original rock from which the smaller pieces broke away. So at other times, the parent rock and the sand and silt we see in soils are hundreds of kilometers apart. So our focus question for this part of the investigation, and make sure you write this down on a piece of paper because I will ask you to answer it when we're done with this part of the investigation. So how do weathered rock pieces move from one place to another? Write that down on a piece of paper, please. So we will use a model to answer the question. A model is a representation of the features and actions of a natural system or a process, but it isn't exactly the same as the real world. It focuses on the most important features. Scientists use models to help them observe what happens in systems that move too slowly or too quickly, or they're too big or they're too small to observe directly. So this is the next setup that you will see. We're going to use the stream table as a model of a piece of land, and the soil is made of two particle sizes, sand and clay. So we have a stream table, some earth material, a standard water source, a ruler, a wood angle, and a container, 1 liter container, a basin, a meter tape, and water. So this part of the investigation, we're going to see if I can help you answer the focus question. How do weathered rock pieces move from one place to another? So this is a stream table, and it's a model of a piece of land. And in this model, the land is composed of soil made of two particle sizes. So we have sand particles and clay particles, and they have been mixed together to make this particular land. So what I have done for this stream table investigation is I have this plastic tray that has a drain hole on the end that is extending over the edge of the table with a basin underneath. And then I have pushed the earth material so it's 20 centimeters from the end of the tray, and it's smoothed down pretty much. I have set a centimeter ruler across the top. It's about 6 or 7 centimeters out from the end. I also have put on, this is a standard water, so you can see the hole at the bottom. It would be like if it was regular rain. And there is a pencil under the tray just to lift it a bit, because there's usually some kind of slope on land. So I have a 1 liter container of water is going to be our water source that I'm going to pour into the small container. And then we're going to see what happens. See if any of this land earth material does any moving from one place to another. Oh. Wow, that came out fast. Supposed to do it slowly. At the moment, it is slow. Gonna let that go down a little bit before I add more. This is gonna take a little while, so be patient. You can see that some of it is starting to move. I gotta be patient too. Oh, wow. Making some move, making some move. Maybe I didn't have it as even as I should have, huh? So I'll pull into that side. You'll get the idea though. Ooh. Slowly but surely. Look at that, folks. Whoa, nice, cool, awesome. So the full 1 liter of water has been deposited. You can see that there's like a little pathway forming in the land. And that could be something like you might call the valley or a canyon. And then as all the water kind of moves forward this way, we might be able to see something else happening.
I think that's your alluvial vein.
Yeah, I think it's getting there. You see the white, which I think is the clay, is moving out farther than the sand. Ooh, we're getting down to the end. Maybe it's going to start hitting the hole and dropping down. Hopefully my bucket's in the right place. Getting close. And our water source container is only about half full now, so keep being patient. And so close. It's stuck. Look at that, and the white clay is moving farther and farther. Sand is just kind of chilling there, even though it's done some moving. Slowly but surely, our rain is raining. Oops, some of the clay is going down. Okay, so the next step is, actually before I do the next step, this would be considered an alluvial fan. So when the earth material comes, and it's not really fan-like, but that's considered an alluvial fan. So on our standard stream table observation, we had an original setup, which the earth material was 20 centimeters out. So now on the standard stream table, I'm going to do my best to draw what I see. So I need to measure out how far that our sand went in centimeters. So it looks to me like the farthest part is 29 centimeters, well, of the sand. But it looks like our clay has come all the way down to 48-ish, huh? So 29. So I don't know. I'm not the best artist, people. Looks like the sand came out a little bit. And so this is sand. And then it looks like, I don't know how to do the clay. So we'll do it, shade it a little darker for sand. And the clay went down to 48, is that right? So we got a little bit of like white clay, which I think I'm just gonna leave like that instead of shading it. And there's a little bit more white clay-ish in that area. And a bigger patch of white going all the way across. So the darker is the sand, and then we have clay in those areas. And I guess I could make it like a little path. So that area is like a valley or a canyon, and our alluvial fan that kind of comes out this way. So after watching the investigation using the standard stream table, now we should be able to answer these following questions. So where did the earth material start in the tray? So it started at 20 centimeters, and where did it go? Well, on the standard stream table, the sand, the farthest part it went was 28 centimeters, but the clay had some particles as far as 48 centimeters away. Now, how does this model show what happens to earth materials in nature? Well, just as the earth material moved in the standard stream table, that can also happen in nature. So when it rains, The water can transport the earth materials to different locations. Now, how do the size of these landforms compare to those we are modeling? Well, the landforms will be much bigger. This is just a smaller version when we use the model. What does this tell us about the effect of flowing water on earth materials? Well, this tells us that flowing water can cause earth materials to move. And you saw the results when I showed the investigation. So now we're going to talk a little bit about landform vocabulary. So erosion is the movement of pieces of weathered rock by water or wind. The settling process is called deposition. The eroded materials that settle are called sediments. These processes create different kinds of landforms. So I want to talk a little bit more about erosion, deposition, and sediments, and then we'll talk about where these different landforms are located on the picture. So one thing you observed in the stream table is called erosion. Erosion is the movement of pieces of weathered rock by water and wind. Erosion changes the shape of the land. So in your stream table, where you saw the depression in the earth through which the stream of water flowed, we can call that a valley or we can call that a canyon. Earth materials that are carried by moving water eventually stop moving and settle out. The settling process is deposition. The eroded materials that settle are called sediments. When the water slows down, sediments are deposited in new locations, somewhere along the path of moving water. So in the stream table, where you saw the fan-shaped materials deposited at the stream or river mouth, we call that a delta or an alluvial fan. The landform created in the stream table is called an alluvial fan because it formed on dry land. The landform created in a bay of water is called a delta, like the one on this slide. So the top, where it's pointing to kind of like that wall that's a little bit deeper, we call that a canyon. And then the next spot down, where it's pointing to the green area, that would be a valley. And then down where the water, the river, makes a fan shape with the earth materials, that's called a delta. So why do you think the clay was deposited farther downstream than the sand? In order to determine that, we're going to do this earth material shakeup. So I'll have a vial with a cap, a syringe, and water. So I'll fill the vial halfway with sand and clay from the stream table. Then fill the vial with water until it is almost full. Cap the vial and shake for 5 seconds. Set the vial down and observe the rate at which different materials settle. Okay, so why do you think that the clay was deposited farther downstream than the sand was? So in order to answer that question, I'm going to do the shake test. So I'm going to fill this, let's see, it wants me to fill it half full with this earth material. I'm just going to scoop. That looks like pretty good half. And then the next step is I'm going to get some water and put it in with the earth material until it's almost to the top. Pretty good. And I'm going to put the lid on and shake for 5 seconds, and then we're going to set it down and look and see what we see. Make sure the lid's on. We'll have a big mess. Whoop, still having a big mess. Shake it over the table.
1, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1000.
Cool. So let's talk about the results. What happened when you shook the earth material with water? So you could see that the sand settled on the bottom and the clay settled on top, and then we just have the water at the very top. Why do you think the sand was deposited on the bottom of the vial and the clay at the top of the sand? If you were thinking that sand is heavier and there are larger particles, then you're correct. So they settled first when the shaking stopped. So what caused the sand and clay to deposit in different places in the stream table? Well, the larger, heavier earth material settled as soon as the water flow started to slow down. The smaller, lighter earth materials, such as clay particles, stayed suspended in the water longer. So they traveled farther and didn't settle until the flow stopped. So how was the settling like the settling in the soil vials? How might the size of the rock particles in soils at different locations be determined by erosion and deposition? So, gang, I told you we would come back to these soil samples that I'd shown you before, and I told you to try to determine where you thought they might come from. Now, knowing about erosion and deposition and the size of the particles, I want you to try again to see if you can determine where these 4 different soils came from. So soil number 1, I think it came from a river delta, a forest, a desert, or a mountain. Soil number 2. Now, if you can find that page where you wrote these down and you want to make some changes, go ahead. If you want to keep them the same, you can as well. So there's bigger pieces in this one. So think about what happens to the size of pieces as they move farther away from their parent rock. Where would you find bigger pieces? Soil number 3. Soil number 4. I will let you know on Thursday where the locations are. So let's go ahead and review some vocabulary. Erosion, the carrying away of weathered earth materials by water, wind, or ice. Deposition, the settling of sediments. Sediments, pieces of weathered rock such as sand deposited by wind, water, and ice. Landform, a feature of the land such as a mountain, canyon, or beach. Model, a representation of the features and actions of a natural system or process. Valley, A low area between hills and mountains, often where a river flows. Canyon. A deep valley with steep sides, eroded by a river. Delta. A fan-shaped deposit at the mouth of a river. Alluvial fan. A fan-shaped deposit formed when a fast-flowing stream, often a flash flood, flows out onto a dry area. River mouth. The place where a river enters another body of water. So now I would like you to answer the focus question. How do weathered rock pieces move from one place to another? Please use the new vocabulary words in your answer. When you have answered your question, take a picture of it and put it on Seesaw or email.